Hello, my name is Eric Proctor. I'm a group screwdriver from Western Carolina University. My group members are Brian and Dex, and we are making a parking curb out of 20-ounce bottles that we are grinding up and melting down.
Hi, I'm Dex. You just met Eric. Our three-man team of screwdrivers came up with our idea based on three assumptions. One, that there are too many bottles in the grass, weeds, curbs, and ditches. Two, that the best way to use them up for now is in bulk products. Three, that since we've hit the peak of oil production and cannot replace enough petroleum with bioresources, just look at the corn ethanol food crisis, petroleum prices will continue to rise ever more steeply, making reclaimable petroleum bulk products more and more valuable. Our idea is to turn bottles into parking lot dividers, those mini curbs currently made of concrete that stop your front tires. Our product will be less dense, lessening transportation costs, while at the same time being more resilient and less prone to weathering and crumbling. The test sample we made was mostly of clear polyethylene terephthalate, PETE, soft drink bottles, which came out a nice concrete gray. But with recent advances in mixing diverse polymers, bottles of various resins should be able to be mixed into the final product, reducing the need for sorting. Not having a large enough vented oven or melting pot available, we were able to produce our test sample by melting shredded bottles in a simple aluminum loaf pan with a barbecue grill.
Hi, my name's Brian. For the actual production of our product, the first thing we did was collected about 30 or 40 bottles from a recycling bin, plastic bottles, and then we took them to our school's regrind machine, fed them through that, and this is what we got after that process. Once we got through with that, we first took these aluminum pans and used this vegetable shorting as a mold release. So we just took this and coated the entire inside of the pan, just so that we would get a good clean release after the mold hardened. For the actual melting of the product, we used two of these pans to melt the product evenly in two batches that were heated at the same time, and then we poured them both into this aluminum pan to form the actual mold.
Okay.
First thing that we did for the heating process was, of course, add our mixture into our pans. Make sure it was nice and even. You don't want any uneven heating of the product. And then we placed it on our grill. It took about probably an hour to get everything nice and uniformly melted. We routinely stirred it to make sure none of the mixture was being heated at the wrong times, wrong levels, and make sure to move it around the grill so it would get even heating. We also made sure to stir it to get the air bubbles out, because any air bubbles that formed later in the mold could possibly weaken the entire structure of it. And we closed the lid periodically when we weren't stirring it, and we have a temperature gauge here. We usually heat it at about 350 to 400 degrees Fahrenheit. We found that if you heat it too hot, it would actually burn it and solidify it. So we figured out that anywhere from 300 to 400, usually around 350 was the ideal temperature for it. After about an hour of heating our polymer mixture and stirring it, we poured it into our mold, and this is what we got out. We got our brick. We let it cool for about 10-15 minutes, and this is what came out.
As you can see, this process can be scaled up and can be used for any kind of disposable plastic. We can do further testing to find out whether we need to add UV protective additives or some kind of coating. It can also be used with any kind of a sheath that you could just pour the plastic into and then use that outer sheath as the exterior surface